Go back again in the loop. Okay. Cytometer.
Okay.
Instrument settings.
Open the caliber file.
Calib file.
Right.
Open.
Okay.
Set.
Set again.
Done. That brings up the red laser to be activated, and then all the other parameters, fluorescence parameters, that change to log, forward scatter, side scatter, and linear, and it's giving you some optimized values for the compensation because it's not 0, 0 for every parameter.
Right.
So you do not have to start from scratch. You can have some values to begin with where you can play.
So all those channel, the channel always the same even in my machine.
Yes.
They should be all.
They should all be the same. It just, in your case, the only difference would be if you're not using this red laser, because your parameter is either here in on 2 or 3, P4 or P5, your FL2 or FL3.
I see.
You know. So I think your parameter would be detected either here or here. So that's what.
So when you plot it, can you? How do you change the parameter in your plot?
How do we change? Yes, that's a very good question. Yeah. So what we're going to do is, let's go ahead and make a plot here. We take a dot plot. I make a plot. I like to spread it a little bit. And whenever this dot plot pops up, I'd like to have all my plots of the same size. So there's something called inspector that pops up.
Inspector.
Yes, and this inspector will come once you click. Once you click on the frame of the dot plot. This is the frame. I click here. I click on the frame. That's when for this plot, all the information is listed here. That what is the type of the plot, what is the tube, what is the x-axis, what is the y parameter, is there a gate drawn? So it gives you, for this plot, it has all the information. No, you're not changing here also. I'll show you where we go and change.
I see.
Okay. So what you're going to do is, at this time, I'd like to make the plot which is acquisition to analysis. That's the best way to look at the data. So whatever your, and then what I will do is, since I have made it acquisition to analysis, at this point I will duplicate the plot. So all plots are of the same size. I go edit. What's happening? Edit, duplicate. So my next plot is just the same, and and if I see it is acquisition to analysis already, because I'm duplicating the same plot. Okay. Then I go and I say edit, duplicate, edit, duplicate. So oops. Now all my plots are the same size. That looks kind of neat. Now, let me make a gate. This is one kind of gate you can have. This is another gate. This is squarish gate, and this is a rectangular gate. So you can use whatever you like. And this is also another kind of gate. This is a quadrant gate. Sometimes people like, they have 4 quadrants. So whatever they like. I prefer this one because it gives me more flexibility to move around the population. So I have it.
Polygon.
Yeah. And what I can do is, I just want to move this because otherwise it's in between. If my cell population is here, I don't want this number to be here. So I just move it. That's a problem in the eye.
Yeah.
Okay. And so I have my gate. Now I just look back here and I say, in this one, in plot number 1, and how I know I'm reading plot number 1, because this is highlighted. If I'm reading this, this is for this plot. Okay. So I just wanted to say here, gate. But in plot number 2, I just want to see populations coming only from P1, because there might be junk and all, which I'm not interested. R1 is region of interest, or the gate, which is region of interest, the cells which you're interested in. You don't want to see everything. So I would here say
Gate.
G1.
G1.
Okay, so that
R1.
is R1, regional
okay.
frequency. Yeah.
Oh,
And then
that's what confused me. So each one is called channel. This one called gate.
yes, yes, this is a channel because you're measuring the parameter.
Right. Yeah.
Whether it is your PI or it is your
Right,
FITC
yeah.
or it's per CP or it's
Okay.
APC. But this gate is this and this has nothing to do with each other because these are totally two different things.
Right. Yeah,
This is the voltage
Okay.
which helps you detect that signal. But
Okay.
this gate is just you are giving the signal
Subpopulation.
to just target the population
I
which
see.
you want to see.
Okay. Yeah. I read the manual. It sounds
No,
so
no, I
confusing.
told you. Somebody was asking me for next Tuesday for a training.
Okay.
And they said, before I come for training, should I read something? I said, it's better to read after the training.
I guess so. Yeah. It's a.
I said, because after you see, it makes more sense when you read it.
Right. Yeah.
If you read it, you're very confused.
Yeah.
So this is what it is.
Yeah.
Now when you go back and read the
I
manual,
will read it again.
it will make so much sense.
Right. Yeah.
Okay, so this is, and then for here, this plot, I would like to say this, and for
Okay.
this one, I would like to say the same, because I don't want all the junk,
Okay.
and I'll show you once I put the cells here,
Okay.
and I will go back and remove the gate, and then I will try to show you what it means that if I don't say no gate, what happens. And you will see all the junk which has come out of that.
Don't grease the diesel gate.
Okay.
No, I'm on the last two right now.
And what is compensation? In your case, compensation is not a very big problem because you're just using one color.
That's an 8.
But what
Although I
can
might have to use also a green color for
Oh, is
light.
it? Okay.
Yeah. So initially I use the PI just for screen, but if I want to publish something, I think
Okay.
I also need to use the